we're going to put this data in there, and then you're going to put your brain on top of it, like your machine learning brain, and that's going to learn from the data, and you're going to get magic out of it. Like we hear the word magic a lot, and I think that's the wrong way to approach it.
AI is turning out to be this magic problem when you look at it on the news or when you look at it on TV. The reality is that AI is an engineering problem.
We have seen firsthand how using machine learning can make a huge impact on these very hard sustainability challenges.
We've gone through a tremendous age of invention where new AI algorithms have been sort of discovered, and now we're going through the age of application where we take all of these things that we've discovered and apply them to each and every business scenario.
Are we harming someone by doing this? So for example, the project that I'm working on right now with the skin cancer is obviously one where you have to look at, okay, so we want to make sure that we're actually finding everything a doctor could find.
And technology is never neutral. Fairness isn't a one-shot process, and we will make mistakes. So it's really important that we anticipate them as best we can, but that we also embrace them and turn them into something positive. So learn from them and let them contribute to our successes.
Welcome to the Global AI Bootcamp 2018, hosted in 67 venues around the world. A full day of learning about AI, organized by Microsoft's most valuable professionals. We hope you have an awesome day.
Hi, welcome to the Global AI Bootcamp. I'm Amy.
Good morning, and I'm Henk. And welcome to one of the 62 venues worldwide.
We really hope you're going to get loads out of today with all of the great AI content, learning about lots of new AI services, and hopefully go away and build with these things straight away.
Over the past few weeks, we had the opportunity to interview and talk to many people of the Microsoft AI teams.
Let's have a look who we spoke to.
My name is Eric Boyd. I run the AI platform team.
I'm Anna Roth. I'm a senior program manager on the computer vision cloud services team.
My name is Seth Juarez, and I'm a cloud advocate for Cloud plus AI developer relations.
Hi, I'm Tess. I'm a developer, a data scientist, a machine learning lead, and I'm also in a couple of AI ethics boards at Microsoft.
Hi, my name is Nilsha Charya. I'm a senior program manager working on automated machine learning in the Azure AI group at Microsoft.
Hi, I'm Damien, and I am a cloud advocate at Microsoft, focused mainly on DevOps, but also DevOps for data science.
I'm Hanna Wallach, and I'm a principal researcher in Microsoft Research New York City.
Hi, I'm Jennifer Marsman, and I'm the principal engineer on the AI for Earth team.
So in this keynote talk, we're going to talk about 3 different themes. One of them is AI for developers. The second one is ethics in AI, and then we'll finish up with AI for good. So Henk, tell me a little bit about your perspective on AI for developers.
As a developer myself, I've been busy learning AI for the last 5 years. And I have to say that it's becoming way easier for developers to get into this space. With the power of the cloud, the availability of Microsoft Cognitive Services, and even the recently released Microsoft Machine Learning Services. So let's have a look about what the Microsoft AI teams have to say about that.
Every developer should think of AI as an alternative way of programming. Instead of you actually having to give the computer instructions, you give the computer data instead, and it learns how to process the data and do the things that you want it to do. So I feel like every developer, number one, can understand AI and can do AI in their current setting and where they work.
I think the biggest mistake that developers make when thinking about AI is that they think about it as just another development technique where if you're more skilled, you will absolutely solve the problem. And in machine learning, it's all about the data and about what the data can give. It's not so much about the algorithms, which we tend to think about more as developers. So thinking strategically about data is super important.
AI has really been driven over the past few years by really 3 fundamental changes. One is the availability of big data, which the cloud makes really possible with things like Databricks and all of our data management solutions. The second is massive increases in computation. So GPUs and then cloud access to lots of them has made that really go. And then the third thing is just new algorithms and new ways to sort of actually compute these different, compute these things. And so you put the three of them together, the cloud is really instrumental in driving AI forward. And so they really, cloud and AI, the two go together for a reason.
So our team builds a lot of core models that are used broadly, internally and externally at Microsoft. So things like image taggers, object detectors, and face recognition that's sort of broadly used. And so I'd say our vision is that any developer ought to be able to use sort of top quality, high quality models with great ease.
But what if a data scientist or anybody else could access an automated service that could identify the best machine learning pipeline for their labeled data set? Ultimately, automated machine learning capabilities empower users with or without data scientists' expertise to identify an end-to-end machine learning solution for any problem, achieving high-quality machine learning models with spending far less of your time trying to achieve your model itself. Automated machine learning can save you time and resources. So whether you have deep experience or not, automated machine learning gives you the capabilities with control and transparency to define your model tuning. The capability iterates to build pipelines to the requirements of your choice. This provides you flexibility to train locally or scale up using AI compute, using data science virtual machines as an example. Automated machine learning provides you the transparency and control, so you can trust the results. You define the experiment setting, such as model performance metrics, time for an experiment to run, amongst other things like blacklisting algorithms. The capability provides transparency by providing your model explainability too. You can view all the pipelines, and you can download the model that you choose, or you can customize it further if you wanted to do so, and the models are ready to deploy.
AI is showing up in really every place across Microsoft. So in many of the Azure services, you'll start to see things like Power BI is now integrated with, AI right in it. You can build a model right from Power BI. You can call cognitive services directly into it. And increasingly more and more areas within Azure are consuming AI themselves. And then the platform itself is just built right on top of Azure. We consume data from Azure Data Lake V2, we spin compute meters, we run batch AI. All the systems in Azure really come together to make the AI platform work.
My three biggest tips, I think, number one, keep everything in source control. All of the code you write should be in source control, just like you're writing a dev project. You should also have a strategy for data refresh and retraining and things like that. If your training data of your model starts getting stale, it's important to know how you're going to do that and how you're going to rebuild your model at the end consistently. And then the third recommendation, I think, is to use some of the tooling that we have. And look, there's other tooling out there as well, but try to create portable models. So models that don't depend really specifically on a piece of hardware, but models that can be deployed everywhere. And Docker seems to be the go-to for that. Wrapping your model in a Docker container means that you can deploy it wherever you want.
As developers coming into the field of machine learning and AI, that's traditionally kind of like an experimental field with no software rigor around it. As developers, where we do have the software rigor, we can make a real difference as far as like making sure that we have models that have proper lineage, like so basically models where this was the data that you got into it, this was the data, and this was the result that you got out of it. And then as you sort of get new data, you know how the models change, but knowing sort of where you twisted and turned the models and the data, like that lineage is important.
So Microsoft has a couple of tools and services available, especially the Azure Machine Learning Service, which is relatively new. And that gives you everything from version control and model management and deployment as well. You can deploy straight from those experiments that you keep. And of course, you can choose any framework you want and make use of, there's features like automated hyperparameter tuning, cloud-based distributed training if you want to use some of the massive machines that we've got in the Azure data centers. There's some really good IDE integrations and all sorts of stuff as well. It's really, really powerful. And then, of course, if you want to really do DevOps properly, Azure DevOps is one of our other products as well. And it's a whole DevOps lifecycle, everything you need from an idea, getting that all the way into production. And it's any language and any platform, which absolutely includes all of your machine learning stuff.
One of the things that bothers me is that AI is turning out to be this magic problem when you look at it on the news or when you look at it on TV. The reality is that AI is an engineering problem. And a lot of the stuff that we do at Microsoft is designed to solve that engineering problem. For example, Azure Machine Learning Service is a great way to actually build machine learning models and actually deploy them with great ease. And it's pretty cool. I didn't have this stuff when I was studying it, and I wish I did.
One of the most exciting things that we've rolled out in the last few weeks is cognitive services available in containers. With really sensors showing up all over the world, the amount of data that companies are going to be sending is really too much for every company to just count on all of their AI running in the cloud. And so we had a ton of demand from customers where they want to be able to run an AI model much closer to their data. And they really want to run our AI models, the cognitive services, the things that we've really hardened and honed and built, you know, special crafted great systems there. And so what we've done is we've made them available in containers, a standard Docker container that they can now run anywhere you can run a Docker container. They can run it on the edge, right next to where the data is being computed, next to some sensor. They can run it on-prem if they have some data that's too private that they can't let out. And so we think it's really going to be great.
Our second topic is ethics in AI. So Amy, tell me a little bit about that.
So ethics in AI is obviously a huge conversation at the moment. Everyone, there's meetups out there talking about it, and that's probably one of the main things that we are talking about it. We're having these conversations, we're learning from each other, whether that's about things that have already happened or whether that's being sort of understanding what data sets we're using, making sure we're working in diverse teams so that our artificial intelligence solutions are actually there for everyone and they make sense for everyone. So we've interviewed a few people, and let's hear a little bit from them.
So over the past few years, we've seen that although AI and machine learning can really enhance human capabilities, we've also seen that these same systems can end up discriminating or disadvantaging already disadvantaged groups. And there are a number of reasons for this, the most important of which is to do with data. We live in a biased society. Society is not fair, and discrimination absolutely happens, and groups are already disadvantaged. When we take data about that society and then train machine learning models to mimic the decisions and uncover patterns reflected in that society, we necessarily run the risk of replicating those same discriminations, those same disadvantages. So I'm Hanna Wallach, and I'm a principal researcher in Microsoft Research New York City. And my research is all about AI and machine learning. In fact, I've been doing this stuff for about 17 years now, so way before it was popular. Nowadays, a lot of my work focuses on fairness, accountability, transparency, and ethics in AI and machine learning. And this is because the many opportunities brought about by AI and machine learning also raise new challenges that really highlight how important it is to get AI right, to make sure that AI and machine learning don't discriminate or further disadvantage already disadvantaged groups. So FATE is a research group in the New York lab that was started a few years ago by myself, Kate Crawford, and Fernando Diaz. And this research group is really focused on these kinds of questions involving fairness, accountability, transparency, and ethics. So FATE. We study a number of different things in this space, and I want to really emphasize that this is an inherently socio-technical group with social scientists such as Kate Crawford, and then core machine learning researchers such as myself, Jen Wortman-Vaughan, and Hal Daume. And we really believe that this mix of social science and computer science is fundamentally critical to understanding issues like fairness, accountability, transparency, and ethics. This is because these kinds of issues typically relate to a broader societal context than a single decision-making system. So in order to understand them, let alone mitigate them, we really need input from a variety of different perspectives, not just those of computer scientists. So some of these circumstances where AI has ended up discriminating or further disadvantaging already disadvantaged groups include the following. So, for example, I'm sure many of you heard about ProPublica's investigation a couple of years ago, which showed that Compass, a widely used recidivism prediction tool, was, according to some metrics, racially biased. As another example, there have been a number of stories recently focused on the various ways in which automated hiring systems can amplify gender bias. As some other examples, we've seen that word embeddings, so a commonly used method for embedding words into a low-dimensional space based on their surrounding words in a corpus of documents, can amplify existing gender stereotypes. As another example, we saw that photo programs can infamously mislabel people in various ways that might be considered cultural denigration. Another example where machine learning and AI systems might discriminate or disadvantage already disadvantaged groups involves speech recognition and face recognition systems. So for example, does a computer vision system actually recognize the person sitting in front of a camera? In a broad sense, these scenarios are also about failing to recognize people's humanity, so respect, dignity, and personhood, not just whether a system works as well for one person as it does for another. So imagine how a user might feel if a system repeatedly fails to recognize her voice, but easily recognizes those of her peers. 3 tips specifically about fairness. So first, it's really important to prioritize fairness at every stage of the machine learning pipeline. Fairness really should be a first-order priority, just like security and privacy. But in order to make fairness a first-order priority, we can't treat it as an afterthought. Instead, we have to actively think about fairness at every stage of that machine learning pipeline, starting with the task definition or the goal, moving through to dataset construction or curation, and on to model specification, all the way to deployment and feedback. My second tip is to involve diverse stakeholders and multiple perspectives. So fairness in machine learning is a fundamentally socio-technical challenge that can't be addressed by computer scientists or developers alone. And while there are some software toolkits and quantitative metrics for detecting and mitigating fairness issues, these are not be-all and end-all solutions, and they're typically only appropriate in really specific limited circumstances. Moreover, fairness usually relates to this broad socio-cultural context rather than just to a single decision-making system. So as a result, we have to involve social scientists, lawyers, policymakers, diverse teams, end users, and other stakeholders to make sure that we're really prioritizing the right issues and taking the right approaches to addressing them. And then my final tip is to adopt a growth mindset and learn from failures. So contrary to what you might read in some articles online, it's not possible to solve fairness. We can't de-bias our models or guarantee that they're bias-free, and technology is never neutral. Fairness isn't a one-shot process, and we will make mistakes. So it's really important that we anticipate them as best we can, but that we also embrace them and turn them into something positive. So learn from them and let them contribute to our successes.
So our third and final topic is AI for good. So Henk, you've been working a little bit in this space. Can you tell us about a project?
Yes, I've been working in this space now for 2 years. Me and my team, we developed an app that is being used in Uganda. It's making use of like face recognition, speech recognition, and it's helping to make medical field workers a bit more effective.
Thanks a lot for sharing that. Let's have a look at a few more people we interviewed about AI for good.
AI projects are fundamentally changing the world in the AI for Earth program. AI for Earth is a $50 million commitment from Microsoft over 5 years to fund people doing machine learning and data science work in the areas of agriculture, water, climate change, and biodiversity. So we have seen firsthand how using machine learning can make a huge impact on these very hard sustainability challenges. For example, one grantee is using machine learning and computer vision to be able to track individual animals. So the company is called WildMe, and their product is called WildBook. And what they are doing is utilizing computer vision to be able to recognize animals to the individual animal level. So not just a zebra or not a zebra, but rather this is Ziggy the zebra and this is Zoe the zebra. So recognizing animals to that individual level. And this can be done with a lot of large mammals. Much like our fingerprints have a unique signature for a human, with zebras, their stripes have a unique pattern. The same thing is true for large cats, large mammal, and other large mammals like elephants have distinctive ears. Whale sharks have distinctive flukes. So using this information, they are building classifiers to allow you to recognize individual animals. And this by itself is pretty cool, but where the story goes from good to great is their innovative use of social media. So every night at 10 p.m., an intelligent agent wakes up and it searches YouTube for videos. So imagine I'm just a regular tourist and I went whale watching and I posted a video of some whale sharks that I saw. Well, this intelligent agent will actually use some natural language processing to find that video and scroll through some of the description to try to find where and when that encounter with the whale shark took place. And then it can actually do some object detection and extract out just the whale from its surroundings and then use that to match against its database of known animals and be able to actually recognize from random YouTube videos an individual animal and track its migration path between in the water. It is just so exciting to see and a much more innovative use of social media than, say, Instagramming your food. And that's why they call themselves WildBook as well. If they think of themselves as the Facebook of wild animals, not only do they track migration patterns, but also individual co-occurrences. So this whale has been sighted with this whale, so maybe they have a family relationship or a friend relationship, or they travel in the same pack, or same pod, I should say, for whales. So it's really, really exciting work, seeing not only the computer vision applications, but also kind of using an innovative source of finding data as well. We also hold twice a year an AI for Earth Summit, where we bring some of the grant recipients of the AI for Earth grant to Redmond, and we spend 3 days with them doing a hackathon, writing some code together, doing some training and education with them, as well as just some great networking opportunities. So you can learn about what people who are doing similar research all around the world are doing in your area. So it would be really cool to see people who are doing maybe agriculture work, trying to predict crop yields, for example. Someone's doing it in India and someone's doing it in North Carolina, and then the two of them getting together, maybe sharing data sets, maybe talking about the ways their research is progressing. So part of it is just kind of building that community as well and helping that community be successful.
Human rights situation often deteriorate very quickly, and the faster we can get the information and we can react to the situation, it can be a real game changer.
New technologies are advancing so rapidly, and technology companies can advise us on how best to use those technologies to protect and promote human rights.
Our objective is automatic damage mapping, because after the disaster, the government needs the damage map to carry out the effective rescue. If we can save the time to grasp the ground damage information, we are able to save a lot of life and facilities.
In a new partnership with the World Bank, United Nations, and tech industry partners, we'll be better able to predict when and where famine will occur.
Operation Smiles's vision really sinks in with what I feel is a fundamental human right.
What the volunteers do for the children may seem like a small thing, but they're able to change the lives of the families forever.
We're creating a chatbot-based experience for refugees coming out of the Syria conflict. The purpose is to have displaced youth find a way to discover and access learning materials. You can engage directly with the course content.
It's just the beginning of the impact that we hope to have with the tools at our disposal.
If you are a developer or a data scientist doing machine learning work in the areas of agriculture, water, climate change, or biodiversity, please apply for an AI for Earth grant as well. Microsoft has pledged $50 million over the next 5 years towards anyone doing data science work in these areas on these hard sustainability challenges. So please don't let this pot of free money go to waste. Apply for a grant.
So firstly, thanks very much for joining us today, and a huge shout out to everyone that's organised each of these events in the 62 different locations that we have. It's not an easy task to do, so just a massive thank you for that.
Thank you all for joining, and I hope you enjoyed the workshops and talks today.
I'm excited about the future of AI. With the amount of data that we produce every day, I can only begin to imagine the kind of things that you'll be able to make.
I think AI will introduce a new set of capabilities in computer programs that make it easier and less tedious for people to accomplish their goals.
I think AI will continue to benefit from awesome DevOps practices.
I think AI will augment humans' capabilities in ways that will positively transform society. However, if we're not careful about how we choose to build and deploy our AI systems and machine learning models, then we risk them reproducing and even amplifying existing societal biases and injustices.
AI will impact our lives more than we know, and will become another point to how we benchmark products and services and their value. As we embark on this fusion of technology, ethics of AI will become an important part of design, usage, and an important milestone for all of our future generations. While we're at an exciting point of evolution, we all have a critical responsibility in how we use AI and our design principles as we move forward.
I think AI will take a while. It will take a while for it to get to the point where it's transparent enough that it can actually be used in proper processes. It will take a while for us to be able to automate without creating fatigue among the people that will actually look at the systems and make sure they do the right thing. Taking, for example, autonomous driving, which is something where we're technically there, but we have issues in that we have to have people still look at the systems, and looking at the systems is boring. Figuring out that equation will take time.
I think AI in the future is just going to continue to expand into every business that's out there. We've gone through a tremendous age of invention where new AI algorithms have been sort of discovered, and now we're going through the age of application where we take all of these things that we've discovered and apply them to each and every business scenario. And you see it internally at Microsoft, where everything from Microsoft Word and PowerPoint have been transformed to the finance team does their forecast using AI, and every company that we talk to is touching every single line of their business, and it's really exciting.
I think AI will fundamentally change how we model, monitor, and manage Earth's natural resources.